Hello students, welcome to SOURAV Sir's classes. Today we would be learning about the normal distribution. A random variable x is said to have a normal distribution with parameters mu and sigma square if its PDF is given as 1 by sigma root 2 pi exponential minus half x minus mu by sigma whole squared, and it is represented as x follows normal with mean mu and variance sigma square. Now, if z is equal to x minus mu by sigma, then it follows normal 0, 1, and over here z is known as the standard normal variate. The cumulative distribution function, that is the CDF, is defined as, or rather is denoted as, phi z is equal to probability z less than equal to z, that is integration from minus infinity to z. Small phi u du, that is 1 by root 2 pi integration from minus infinity to z e to the power minus u square by 2 du. Now there's a result regarding CDF, that is phi of minus z is equal to 1 minus phi z given z greater than 0. This can be proved as phi of minus z is equal to probability z less than minus z, which is equal to probability z greater than is equal to z. We got this because a normal distribution is symmetric. I would be coming to these characteristics later in the video, which is equal to 1 minus probability z less than equal to z, which is equal to 1 minus capital phi z. Now, moving on to the characteristics of the curve. So the normal curve is like this. It is bell shaped and is symmetric. The mean, median and mode, these all coincide. The x-axis, this is an asymptote to the curve. The MGF of the normal distribution is given as mu xt is equal to e to the power mu t plus half sigma square t square. Now this is the case when x follows normal mu sigma square, and for a standard normal variate that is z follows normal 0, 1. The moment generating function is equal to e to the power t square by 2. Thank you for watching this video and stay tuned to our channel SOURAV Sir's Classes for further videos on statistical concepts.